Okay, Assalamualaikum and good evening, everyone. Today we will be discussing about trace contaminants in complex samples, low concentration pollutants, and our chosen substance for today is mercury. So, before I start the discussion, I will start with identification of hidden substance and contaminants of mercury first. So, the hidden substance identified in this investigation is mercury, a toxic heavy metal. Mercury is considered a hidden contaminant because it can be present in food, water, soil, and consumer product without being easily detected. Other than that, mercury also exists in three main forms, which is elemental mercury, inorganic mercury compounds, and organic mercury. For example, metal mercury. Exposure to mercury can cause serious health effects, including damage to the nervous system, kidneys, and brain development in children. So, Marsha, what is your investigation for sources and associated risks for mercury?
For organic mercury, this is the type of mercury the average person is most likely to encounter. It is an environmental pollutant that bioaccumulates in the food chain. In, when ingested, methyl mercury crosses the blood-brain and placental barriers and causes adult neurological deficit and irreversible fatal neurotoxicity. Okay, for elemental mercury, this is the shiny silver liquid metal that rolls into tiny balls when spilled. It is usually found in older barometers, thermometers, and industrial processes. If breathing the vapor causes acute chemical pneumonitis. Lastly, for inorganic mercury, it's usually used illegally or found in unregulated consumer products because mercury compound can aggressively block the body's production of melanin. It will cause skin absorption. It target the proximal tubules of the kidneys, causing acute tubular necrosis and renal failure. That's all from me.
Okay, so thank you, Marsha, for your explanation. Next is suitable analytical technique for mercury. So, Balkis, what is your investigation for the techniques for mercury?
Since mercury is a heavy metal and can exist at very low concentration in complex sample, um, atomic absorption spectroscopy (AAS), especially for cold vapor AAS, is the most suitable analytical technique. This method provides high sensitivity and accuracy um, for detecting mercury in environmental samples such as water, soil, and biological tissue. While atomic absorption spectroscopy, why we use why we don't use HPLC and GCMS? It is because mercury is inorganic metal. Why these techniques are mainly designed for organic compound. That's all from me.
Okay, thank you, Balkis, for your explanation. Miza, what is the relevant case studies or real world incident for mercury?
I think for our topic that the most suitable case I think is Minamata Bay Mercury disaster because it perfectly illustrates how a trace contaminant can mask itself within a complex environmental background. In this case, an industrial plant discharged a low trace level of inorganic mercury into the bay, which an aerobic microbe in the complex sediment chemically transformed into highly toxic methyl mercury. This organic molecule then biomagnified up the marine food chain into local fish, proving that even minute concentration can cause devastating neurological poisoning when hidden inside a dense biological matrix. Today, detecting this trace level require advanced methods like ICP-MS or cold vapor automatic fluorescence spectroscopy to eliminate background interference. Reflecting on our group process, our biggest challenge was deciding between a modern synthetic or a historical case study, but truly collaborative decision making. making, we realize Minamata perfectly highlight how trace element move through an entire ecosystem, forcing us to think critically about sample metric dynamic. That's all.
Okay, thank you, Miza. So Iqua, what is the proposed methods for detection, monitoring, and prevention for mercury?
Both me and Bella did the proposed methods for detection, monitoring, and as well as prevention. I think we can do a regular sample detection by collecting samples such as water, sediment, and also fish, and analyze them using CVAAS, which is what we call as cold vapor atomic absorption spectroscopy. It is a highly sensitive and specifically designed for mercury analysis. And by testing these samples regularly, we can identify mercury contamination at an early stage before it becomes more serious. And as for monitoring, I think a continuous monitoring program should be established, especially in areas located near factories, mining sites, or other industrial activities that may release mercury into the environment. And the samples should be collected and analyzed monthly or quarterly, depending on the risk level. So the results should be recorded so that the changes in mercury concentration can be tracked over time. So it can help authorities to identify pollution trends and take action quickly if the mercury levels begin to exceed safety limits. So next, I will pass it to Bella.
For prevention, I think there are two prevent methods. The first one is industry must take responsibility for treating their wastewater properly before they releasing into the environment. They should also ensure that their waste management practices comply with environmental regulation to minimize the mercury contaminated. In addition, I also think that the public play an important role, which is people should be encouraged to recycle products that may contain mercury, such as batteries, electronic waste. So by disposing of this item correctly, we can reduce the amount of mercury released to the environment. That's all from me.
Okay, thank you, Iqua and Bella, for the explanation. I think that's all for our discussion today. We will continue discussing more about the details of mercury later in our presentation. So thank you everyone for today.